Hello and welcome to Math with Mrs. Becker. Today we are looking at College Algebra 1.4 Day 2. Our primary focus for today is to figure out the correct order that you apply transformations. So here is a list of the various transformations that we have been studying, showing you the order that you need to perform these transformations. Horizontal size changes. So those are stretches and compressions, also known as shrinks. They always go first because they are in parentheses and you're multiplying. If you reflect over the y, that would go second. Again, it's in parentheses. It's a negative. So you are multiplying by a negative. So both of these two, you are multiplying inside of parentheses. Notice the number comes first. The number, whether you're doing a stretch or a compression, that comes before a negative sign that would flip it over the y-axis. Next, we're staying with horizontal because it's in parentheses. So just like the order of operations, you have to do parentheses first. Horizontal translations, you're adding and subtracting. That's why they come after your size changes and your reflections, because just like the normal order of operations, you would multiply before you would add and subtract. Once you have taken care of everything that is in parentheses, now we go ahead and look at the vertical transformations. Multiplying comes first. So our fourth transformation would be a vertical size change, meaning stretches or compressions. Again, that is a number. Okay, the number comes before the negative because a negative, you're still multiplying out front. Number comes before a negative. Last but not least, if you are doing a vertical translation or a slide shift is what else they're called. You're just adding or subtracting to the end, so those go last. So to practice this idea, it says assume that the parent function is f of x equals x squared. So that's the parent. That means any changes or anything that you see other than the x in the power of 2, that is a transformation. So we need to describe the transformations that take place in order. Okay, so the first thing you want to look at is in parentheses. Yes, we have a change in parentheses. We have a -4. So if you're adding or subtracting, it's a horizontal shift. Remember, the formula has a minus. This remained a minus. That means I filled in a positive number. So this is a horizontal shift to the right 4. There is nothing else in parentheses. So now if I look, I have a 2 and a 5. The 2 is being multiplied. Multiplication comes before addition. If it's out front, it's vertical. Vertical, you keep the number how it is. This is a 2. 2 is bigger than 1, so this is a vertical stretch. So that would come next. Last but not least, I have the +5 at the end. Anytime you add or subtract to the end, that's a vertical shift. If I look, this says +5, so I am going up 5. So there is our first example. What transformations occurred, and then you need to number them so we know the correct order that they occur. Let's look at a couple more. Again, our parent function, we're still staying with this x squared. In parentheses, you always look in parentheses first. There is a transformation in parentheses. It is adding or subtracting. Adding or subtracting is a translation or a shift. So I have a horizontal shift. The formula is a minus. This is now a plus. That means I minused a negative, so we're actually going to the left 2. No other changes are taking place in parentheses. So now we look at the other changes. I have a multiplication by a negative. This is not a negative 1/3. The 1/3 is going to shrink it. The negative is going to flip it upside down. They are two separate things. They're both multiplication. Then I have a subtraction. Multiplication comes first. The number is more important than the sign. So I need to take care of the 1/3. 1/3, it's out front, so it's vertical. 1/3 is less than 1, so it's a vertical shrink or compression. Then I have a multiplying by a negative up front. Anytime it's a negative, that is a reflection. If it's out front, it's a reflection across the x-axis. Last but certainly not least, I'm subtracting to the end. Adding and subtracting is always a shift. This is at the end, so it's vertical. So we have a vertical slide, shift, or translation. It's -1, so we would travel down 1. There's our second example. Main thing is you get in the habit of numbering what order do these transformations occur. Okay, let's go ahead and look at example C. Again, based off of the parent function, x squared. Look in parentheses first. I have 2 transformations in the parentheses. Multiplying by 1/2 and subtracting 2. Multiplying comes before subtraction. It's in parentheses, so it's horizontal. In order to figure out if we have a horizontal stretch or a compression, remember you always do the reciprocal if it's horizontal. Our value is 1/2. The reciprocal is 2/1. The reciprocal is larger than 1, so this is a horizontal stretch by a factor of 2. Then inside, I'm subtracting. It's in parentheses, so it's horizontal. Adding and subtracting is a shift or a slide. The formula is a minus. This remained a minus. That means I put a +2 in there. If I placed a +2 in there, we are traveling to the right 2. And you guys, this is what it's going to be like now. So you're doing all those transformations that we've been covering for a while now. We saw them a lot in Algebra 2. Now it's just applying the fact that, hey, you have a correct order to do this. So let's go ahead and keep working on them. Kind of fun. Assume the parent function. Now this, we have an exponential function because our variable is an exponent. So I have 2 to the power of x. Now, instead of having parentheses when something is horizontal, the way that you will know that it's only going to the x is it will remain in the exponent. So any change that occurs in the exponent, that means that it's only happening to the x, so that is equivalent to it being in parentheses. Okay, now the first one, this drives me crazy. I'm going to go ahead and rewrite this. They have 2 to the power of 0.25x. Well, when we're doing horizontal stretches and compressions, remember we have to do the reciprocal. So rather than looking at that in decimal form, right away I wanted to go ahead and change that into a fraction so then I can easily just flip it. Okay, again, there is only one change here. The 2 is part of the original parent function, so is the x. The only change is this 1/4. The 1/4 only applies to the x because it remained in the exponent, so it's horizontal. It's multiplying. If you're multiplying, it's a stretch or a shrink. Okay, so what you have to do to figure out what it is, because it's horizontal, you need to go ahead and flip it upside down. So 1/4, take the reciprocal, it's 4. 4 is bigger than 1, so that is a horizontal stretch. Next one, again, the changes are all inside of the exponent, so that means that they're going to be horizontal. I have multiplying by a negative and then adding. Multiplication comes first. When you multiply by a negative, that's always a reflection. If it is only to the x, it's a reflection across the y-axis. Then we're adding. It's only going to the x, and I know that because it stayed within the exponent. The formula for a horizontal slide has a minus. This is now a plus. That means I placed a -3 in there, so we have a horizontal slide to the left 3 because we have to go that negative direction. Okay, last one. I have a 3 and a -1 that is going with the x. Now again, that is equivalent to having it in parentheses. So those would have to go first. Then I have a negative out front and then a +2. So I have a lot of transformations here. Let's give myself some room. So number one, this is the same as in parentheses. You multiply before you subtract, okay? So multiplication, it's a horizontal. If it's horizontal, you need to do the reciprocal. The reciprocal of 3 is 1/3. 1/3 is less than 1, so that is a horizontal shrink. 2, staying with the x, because technically it's in parentheses. It is adding and subtracting, so it's a horizontal slide. The formula is a minus. It remained a minus, so I am going to the right one. Now what I have is a multiplication by a negative and adding a 2. Multiplying comes first. So it's a reflection across, can't write and talk at the same time. A reflection across, this is the x-axis. Remember, when you have a negative out front, it flips everything upside down. Then I'm adding at the end, because it's at the end, it's vertical. Adding and subtracting is a slide or a shift. Because it's +2, we are going up 2. Okay, so this whole front side, it was examples, just getting us comfortable with, hey, guess what? There's actually a correct order that we need to do this. When you are graphing transformations of parent functions, it is important to change the ordered pairs in the correct order. Because if you don't change the ordered pairs in the correct order, you will not end up with the correct transformation image at the end. So we're going to go ahead and flip this over, and we are going to do this. You guys, it's going to be awesome. The parent function is that absolute value function, and here are the ordered pairs that we want to work with. So step one, I'm going to go ahead and write this in table format, because just like we looked at in 1.4 part 1, we need to continuously be altering the ordered pairs. And I do think it's a little bit easier to do that if we have it in table format versus just a list of ordered pairs. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So again, what does that parent absolute value function look like? It has that sharp point. It is a V. Its vertex point is right there at the origin. That's what we're looking at. Okay, we need to figure out the transformations that occurred in order, and then we have to go ahead and change the order pairs in order as well. Okay, I have a negative out front. Now, if you have something within the absolute value bars, that is inside of brackets, so it's the same thing as parentheses, and then a +6. So anything that applies to only the x goes first. So my first transformation, this is technically in parentheses. I'm subtracting, so it's a shift. So I have a horizontal shift. This remained a minus, so I'm going to the right 3. The way that you change the order pairs, this is horizontal, so I'm changing the x's. To go to the right 3, that's the positive direction, so I add 3 to the x's. I do not change the y's. So we're going to go ahead and do our first transformation. Take all of the x's and add 3. -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. We did not change the y's in that first step. Now, we don't graph this, because this would be if we wanted to graph just that piece. We want to graph the whole thing. We took care of the first transformation, okay? So now we need to use these ordered pairs to continue. The next transformation, I do see that I'm multiplying 2 things. The number comes first. The number, it's outside of the bracket, so it's vertical. It's multiplying, so it's a stretch or a compression. 2 is greater than 1, so it's a vertical stretch. Because it's vertical, we have to change the y. Stretches and compressions, remember, you're always multiplying by whatever the factor is. Here, our factor is a 2. So we are multiplying the vertical variable. So in this case, the y. We have to multiply the y's by 2. We're keeping the x's the same. So here is my second change. My x's are staying the same this time. So 1, 2, 3, 4, 5. I have to take all the y's and multiply them by 2. 2 times 2 is 4. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. So now I've taken care of, I did this and I did this. I have a negative out front. This is a reflection across. Remember, if it is, I cannot write across today. If it is out front, it is across the x-axis, because what it does is it flips it upside down. If you are reflecting across the x-axis, that means you keep the x the same, you change the signs of all the y's. So here we go, I gotta make my little XY table a little bit smaller here. I'm keeping the x's, 1, 2, 3, 4, 5. I have to change the sign of all of the y's. This becomes -4, -2, 0, -2, -4. So now I took care of the negative. Last but certainly not least, I have a fourth transformation. We're adding at the end. Because it's at the end, it's vertical. It is a slide. If I'm adding 6, that means I'm going up 6. The way that we change the ordered pairs, it's vertical, so I'm changing the y's. To move this up 6, that's the positive direction, so I need to take all of the y's and add 6. So I have 1, 2, 3, 4, 5. I did not give myself a lot of room here. Take every y and add 6. -4 plus 6 is 2. -2 plus 6 is 4. 0 plus 6 is 6. -2 plus 6 is 4. -4 plus 6 is 2. Now, this is the set of ordered pairs that show you g of x, because g of x has all of these transformations. So you don't graph until you have completed all of the various transformations that occurred. So now I can go ahead and graph this. I go to the right 1, up 1, 2. There's a point. I go to the right 2, up 1, 2, 3, 4. There's a point. I go to the right 1, 2, 3, up 1, 2, 3, 4, 5, 6. So it's a little bit off the graph. Sorry about that. Go to the right 1, 2, 3, 4, up 1, 2, 3, 4. And I go to the right 1, 2, 3, 4, 5, up 1, 2. Here is g of x. So what happened to that thing? It got slid to the right 3, then it stretched vertically, so it got taller, which in turn made it more narrow. It got flipped upside down and then slid up 6. So this is how you actually graph transformations. You do need to make sure that you are keeping track of the ordered pairs, but you only graph the final set. Let's do another one. Okay, the parent function is the square root of x. That's where we're starting. Here are the ordered pairs we are starting with. So 0, 0, 1, 1, 4, 2, and just for giggles, we went 9, 3. Obviously, when we graph the parent, we are not going to the right 9 units. It's kind of wild. Okay, so we're just going to be able to show these 3. But as we do transformations, this may end up as a value where we can show this on the same grid. So 0, 0, 1, 1. Go to the right 1, 2, 3, 4, up 1, 2. There is the parent function. Now that is what we are changing. Here are all of the changes. So I started off with the square root of x. Anything that is underneath the square root, that is equivalent to being in parentheses because it's only being applied to the x. Okay, so the first thing that I see is underneath. I have multiplication 2 ways, a negative and a number. The number goes first. So it's a horizontal. Because it's horizontal, you have to do the reciprocal. The reciprocal of 2 is 1/2. So this is a horizontal shrink by a factor of 1/2. The way that you change your order pairs. Because it's horizontal, you're changing the x. The reciprocal of 2 is 1/2, so we have to take all of the x's and multiply them by 1/2. It's horizontal, so we are not changing the y's. So 1/2 times 0 is 0. 1/2 times 1 is 1/2. 4 times 1/2 is 2. 9 times 1/2 is 9/2. Keep the y's the same. 0, 1, 2, 3. So I took care of the 2. Now there's a negative. That negative is technically in parentheses because it's underneath the symbol. It is a reflection because it's only going to the x. It's a reflection across the y-axis. If you are reflecting across the y-axis, you keep the y the same. What I have to do is change the x. And the way that you change the x is you have to change the sign. So anything positive becomes negative, anything negative becomes positive. There is no such thing as a negative 0. Okay, 0 is neither positive nor negative, so that remains. This becomes a negative 1/2, a negative 2, and a negative 9/2. The y's did not change for that step. So we are done with the 2 and the negative underneath the symbol. Now we have a -3 at the end. Because it's at the end, it's vertical. Adding and subtracting is a shift or a slide. If you -3, we are going down 3. Now this time when I change the order pairs, it's vertical, so we change the y. Y, if I want to go down 3, I have to take all the y values and -3. So this time I'm keeping the x's. 0, negative 1/2, negative 2, negative 9/2. Take the y's. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. Now if you look, we've gone through all of the transformations. So I can go ahead and graph the last set of ordered pairs. So 0, go down 1, 2, 3. Go to the left 1/2 and down 2. Go to the left 2 and down 1. Now negative 9 over 2 is negative 4.5. So go to the left 1, 2, 3, 4 and a half. That stays at 0. Here is my transformation function. What happened is it did a horizontal shrink. It flipped over the y-axis. That's why it's facing the other direction. And then it shifted down 3. Okay, transformations do not only apply to parent functions. Okay, you can transform crazy graphs, which is kind of fun, and that's what we're going to do right now. Okay, it says you can use the rules for transformations to graph any function. They would still call the beginning the parent function, even though it's not necessarily linear or quadratic or cubic. Okay, it's just parent because that's where you started. So here's an example. Given the graph below, that's the parent function, identify the ordered pairs and then graph the following functions on the same grid, okay? So here, this is the ordered pairs. Okay, here we go. The ordered pairs that I see. This is my x and y axis. So if I go to the left, 1, 2, 3, 4, 5. I have a point that's negative 5 and 0. This point, I go to the left 2 up 1, 2, 3. So it's to the left 2 up 3. Now this one I stay at 0 and I go up 2. Here I go to the right 2 up 1, 2, 3. So 2, 3. Here I go to the right 1, 2, 3, 4, 5, 6. Go up 1, 2, 3. So it's 6, 3. So these are the points that are going to get me back to this graph. If I go ahead, and this is what the transformations I want to do would be, in parentheses, okay, in parentheses it's going to the x. So step 1, it is reflect across the y-axis because the negative is only going to the x. If you are reflecting across the y, that means you keep the y the same, you change the x's. So I'm going to go ahead and do that. I'm changing all of the x's. So 5, 2, 0, negative 2, negative 6. I'm keeping the y's. 0, 3, 2, 3, 3. Now I have a 1/2 being multiplied out front. If it's out front, it's vertical. 1/2 is less than 1, so it's a vertical shrink. Because it's vertical, we are changing the y. Stretches and compressions, you multiply by whatever the factor is. The factor is 1/2. So this time, I keep the x's the same. 5, 2, 0, negative 2, negative 6. Now you take all of the y's and I have to multiply it by 1/2. So 0 times 1/2 is 0. 3 times 1/2 is 3/2. 2 times 1/2 is 1. 3 times 1/2 is 3/2. 3 times 1/2 is 3/2. Now here I did the negative and I did my vertical shrink. This set of ordered pairs would represent this. Flip it over the y-axis, and then you would go ahead and shrink it. Let's graph this. So if I go to the right 1, 2, 3, 4, 5, I stay at 0. If I go to the right 2, I go up 3/2, which is 1.5. If I stay at 0, I go up 1. So right now, this is what we have. Oh, that's not a very straight line. There we go. Okay, now if I go to the left, 1, 2, I go up 1.5. And if I go to the left, 1, 2, 3, 4, 5, 6, so off the graph, it's still up 1.5. So it goes to here and to there. So just showing you that you can still do this even with something that is not a basic parent function. To save us time, because I am noticing that these notes are taking quite a while, okay, and it's the same process all the time, we will just go through and figure out what you would do with the ordered pairs versus graphing them, because I'd love to keep this around 30 minutes or less, okay? So here is the transformation that you're doing, okay? If it's in parentheses, you know it's going to be horizontal. Multiplication comes before addition and subtraction. So this would be a horizontal. Because it's horizontal, that's why you do the reciprocal. The reciprocal of 2 is 1/2. So this would be a horizontal shrink. The way that you would change the ordered pair, it's horizontal. So you would multiply that factor, which is the reciprocal of 2. So you would multiply the 1/2 by the x's, keep the y's. Then to look at the -4, it's in parentheses, so it's a horizontal slide or shift. The formula for horizontal contains a negative. Because it remained a negative, it means that we are going to the right 4, the way that you would change the order pairs. Horizontal, so you would take the x's to go to the right, that's the positive direction. You would add 4, you'd keep the y's the same. So what you would do was start off with these ordered pairs. To get the second set, take all the y or all of the x's times 1/2, keep the y's the same. Then you would take those ordered pairs, add a 4 to the x's. I don't know why I can't spit this out. Add a 4 to the x's, keep the y's the same, and then you would graph that set of ordered pairs. Last one. F of x just means that you're starting off with some set of ordered pairs. There are 1, 2, 3 transformations. There's 3 things that you're doing to that function. Multiplying by a negative, multiplying by a 2, adding a 3. Multiplication comes before addition. The number comes before the negative. So it's vertical. 2 is greater than 1. Because 2 is greater than 1, it makes this a vertical stretch. The way that you would change the ordered pairs. Because it's vertical, you are multiplying the y value by the factor. It is 2 times y. Remember, with vertical, you do not do the reciprocal. You keep it how it is. The first ordered pairs, the first time you change them, because it's a vertical stretch, you do not change the x. Vertical means you change the y. You're multiplying by the factor, which is a 2. Got that. The second thing is you're going to go ahead and look at that negative. Negatives are always a reflection. If it is out front, it is a reflection across or over the x-axis. If you are reflecting across the x, you keep x the same. You change the signs of the y value. Then last but not least here, I'm adding a 3 at the end because it's at the end. It's a vertical slide. Because it's plus 3, you're going up 3. The way that you would change the order pairs. Because it's vertical, you leave the x the same. You change the y. To slide up 3, you add 3. So in order, you would take the order pairs. Your first change, you would keep the x's, multiply all of the y's by 2. Then you would take that set of ordered pairs, keep the x's, change the sign on all of the y's. Then you would take that set of ordered pairs, keep the x's, add a 3 to all of the y's, then you could go ahead and graph the final set of ordered pairs to see what this transformation function looks like. We made it right at 30 minutes. I hope you guys had a great time learning about the order of transformations. Take care, and I'll talk to you soon.